Hello everyone, for this video we're going to talk about quartiles for ungrouped data. Of course, let us have our learning target first. So we have I can determine the quartiles of an ungrouped data. So here's the guide questions that hopefully you can answer after watching this video. Now, before we proceed with our discussion itself, let us have first a short drill wherein you are supposed to determine the median of the following sets of numbers. Now, hopefully you can still remember what is median, or of course, if you are going to recall or think of some other words that is somehow synonymous with median, I know you remember the word midpoint or center, and yes, it's correct, of course. But of course, let's make use of our values or numerical values, guys. So let's say we have our scores 85, 90, 90, 87, 93. So how are we going to find the median of this set of data? So first of all, you need to arrange this in either ascending or descending order. So it doesn't matter either of those order. So let's say I'm gonna arrange this in ascending order, and let's identify the median or the value that is in the middle position of all this set of data. Okay, so now as you can see, we do have here 5 scores. If we're going to arrange this in ascending order, we would have 85, 87, 90, 90, 93. So we do have 5 scores here. Now, since we do have 5 datas, we all know if we're going to take a look or observe the given position, so where do you think is our middle score or middle number? So out of these 3 given scores, so of course our third value, and that would be 90. So for some, what if we do have our given set of data like this one? We do have a lot. So 2, 4, 6, 8, 9. So what do you think are the best way for you to easily identify which position do you think represents the median of the set of data? So you may use this formula. Since we do have here 9 scores, just simply add by 1 and divide by 2. So since we do have here 9 plus 1, it's 10. So 10 divided by 2, it's 5. So that means you arrange it first in either ascending or descending order, and you count which value is the fifth in the rank or in the position. So that means my answer here is 18. So you double check. Okay, and next is same manner, you just arrange it in either ascending or descending order. This time let's count how many numbers: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11, so plus 1, it's 12. 12 divided by 2, it's 6. Therefore, let's arrange this one first in either ascending or descending order, and then let's find out which value is in the 6th position, and that is our median, and our answer for that is 52. And lastly, what if we do have this set of data? We do have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 even numbers. So 10 plus 1, it's 11, divided by 2, it's 5.5. So which do you think? Maybe you are in doubt if what should I choose? Is it the 5th position or 6th position, since it's 5.5? Actually, you are supposed to involve or include the 2. So you need to find out what is or what number is in 5th position and in 6th position, and then you are supposed to get the mean of those 2 numbers. And if you're going to arrange all of this, so we would have 13 is the 5th number, and 16 is the 6th number. So with that, I'm gonna add 13 and 16, then divide it by 2, and I would have 14.5. So this will be our easy steps on how to get the median of our set of data. Okay, so before we move on to our practice exercise, of course, let us just have a short recap of what is median. So let's define it. Median divides the distribution into two equal parts. It is a point in the distribution where one half of the distribution lies below it or above it, right? But of course, sometimes or mostly we encounter instances wherein we are wondering of what do you think will be the score of the lowest 10% of the class? Or what is the scores of those 10% high or higher scorer in this class, right? So that is why, aside from having this concept about median, we also have another measures of position so that we can identify what is the score of this lowest 20% of this set of data, or what is the score of those students that belongs to highest 30% of this class and whatsoever. So we have quartiles, percentiles, and deciles. So to make or to give you an overview, if we talk about quartiles, that means the data is divided into 4 equal parts. And for percentiles, so the data is divided into 100 equal parts. And for deciles, the data is divided into 10 equal parts. But of course, for this video, we will just simply focus on quartiles. So don't worry, in our next video lessons, we will be discussing as well percentiles and deciles. Okay, so what is quartile or what are quartiles? First, the quartiles are points that divide a ranked data into 4 equal parts. Each set of data has 3 quartiles. So to understand thoroughly, let us have this illustration. So we all know a entire group or a whole group is represented as 100%, right? If we're going to divide it into 4 equal groups, then that means each group would be 25%. And now, if we are pertaining to values, scores, numbers, we couldn't deny the fact that we do have our lowest number or lowest value and then the highest value. And of course, to determine our quartiles, so as mentioned here, each set of data has 3 quartiles. So here, the division between these two lower 25%, these two groups, would be our quartile 1. And of course, this one, the middle division, would be our Q2. And lastly, the Q3. Okay, now, let's have here a short hint on how are we going to give interpretation. So I'll just give you some tip on how to do this. So using this visual representation. Now, at most 25% or 10% of the students got a grade in math less than 82, and at most 75% or 30 students get higher than 82. Where did I get this number? Let's just assume that I am solving for Q1 of the data regarding the grades of your section in math last term 1. And let's say I'm done computing the Q1 and I got 82. So how I am going to give interpretation to that information? So again, I get 82, and let's assume that you are 40 in your class. Now, so if I'm going to represent or I mean interpret the data result that I've got, so I'm gonna use or I'm gonna state it this way: at most 25% or 10 of the students, since we are referring to Q1, as you can see, we have here 25% lower than the Q1 score, okay, or value. Okay, so or 10, how did I come up with 10? So you just simply get what is 25% of 40 students. So you just apply the formula for base rate and percentage. So 40 times 0.25, you will get 10. So 10 of the students got a grade in math less than 82 because 82 is our Q1 here. And if you're going to look at the right side of our Q1, we can see 325s here. And with that, we can say at most 75% or 30 students got higher than 82. So, as easy as that. So, that would be the pattern in making your interpretation. Now, so to make it more specific, so what is our first quartile? So, we represent first quartile as Q1, and it is also known as lower quartile. And guys, take note, as you can see here, the description on first quartile, this will be your guide as well in making your interpretation. So, almost the same. Okay, next, quartile 2, this is also known as our median. And the representation for our second quartile is Q sub 2. Okay, next is, how about third quartile? So, third quartile is represented by Q sub 3, and it is also known as upper quartile. And then you visualize again, guys. So as you can see here, how are you going to interpret third quartile? It's mentioned here, Q3 is a number such that at most 3/4 or 75% of the data are smaller in value than Q3. Somehow it's just a vice versa of your Q1. So I do hope you can now visualize what would be the scenario. And most 1/4 or 25% are larger. Ayan. And then, again, Q3 is sometimes called the upper quartile. So guys, here's the formula on how are you going to find 4 quartiles of ungrouped data. But take note, guys, this formula didn't give you the exact value, number, or score already of your Q1 and Q2 or Q3, but rather this would tell you the position or the rank of your Q1, Q2, Q3 score or value. So what would be the formula? So to find the position or rank of your Q1, you just simply use n plus 1 over 4 or divided by 4. And as you can see, we do have here TH, observation. So since we're talking about position or rank, so that is why if you observe, if we're talking about rank, we do have first, we have ST, second ND, third RD, fourth TH, 5th with TH, 6th with TH, 7th with TH, and so on. Okay, same manner with Q3. So the formula would be 3 quantity n plus 1 all over 4 observation. So of course, if you're going to find the Q2 or the median, you just simply modify this formula. So instead of having 3 quantity n plus 1 divided by 4, you just change the 3 into 2, and that would tell you the position of your median as well. But of course, you may also use the strategy that you've used during our drill in finding the median, so that would give you the same answer as well. Okay, so let's have this practice exercise. Let us have our first problem. So we have find the Q1, Q3, and then the interquartile range. Now, before anything else, maybe let's start with identifying our n or the sample size. So how many scores or values are given here? So 1, 2, 3, 4, 5, 6, 7. So that means our n will be 7. Now, let's start with our formula, of course, to identify our position of our Q1 and Q3. But let us have a range as well. Okay, our data in either ascending or descending order, but here I'm gonna use ascending order. Now, to find the position of our Q1, so I'm gonna use the formula first. So 7 plus 1 divided by 4. So I would have 8 divided by 4. So I would have 2. But 2 is not directly the value of your Q1, but instead this is your position or your rank, and therefore that indicates second observation. And with that, you need to look for which score is your second in the rank or in the position. So we have here, you just simply count, so 1, 2. So that means your Q1 is 18. And as easy as that. Now let's move on to our Q3. So same manner, to find the position first of your Q3 score, so just simply substitute first all the data necessary here in our formula. So 3 times 7 plus 1 is 8. So 3 times 8 is 24. 24 divided by 4, you would have 6. And of course, let's make it complete. 6 observation. Okay, so since we got 6th observation for our Q3, let's count again which value is our 6th in the rank. So 1, 2, 3, 4, 5, 6. So this one. So that means our 6th in the set of data wherein we arrange in ascending order is 39. Therefore, your Q3 is 39. As easy as that. But last one, how are we going to get the interquartile range? So very easy. What would be the formula? You just simply use this Q3 deducted by Q1. So here we got our IQR, or I'm gonna use the acronym because it's very long. So IQR Q3 is, we got 39. 39 minus our Q1 is 18. Therefore, our interquartile range would be 39 minus 18 is 21. And you're done with this problem. Okay, so for our next practice exercise, so same manner, we are going to solve for Q1, Q3, and interquartile range. I'm gonna start with finding the N. Our N here is 9. Now, let's start rewriting our formulas, and of course, I'm gonna share to you the data wherein I arrange already in ascending order. Okay, so let's find the position of our Q1. So we have 9 plus 1 divided by 4. So we would have 10 divided by 4. Oh, our answer here is not a whole number. And with that, what are we going to do if this is the case? So if this is the case, guys, you just simply, since we got 2.5, so it's in the middle of second and third rank, so you just simply get the mean of the second and the third score or third number in the set of data that you've arranged. So let's count first. Where is your first? Second and third. So first, second, and third. So therefore, we are supposed to combine this one, 32 and 37. So now, we can have Q1 is 32 plus 37, but since it says mean, therefore divide it by 2. So with that, we would have 32 plus 37, it's 69 divided by 2, so we would have 34.5, and this is your Q1. Okay, so how about for Q3? So same manner, guys, let's identify first the position of our Q3. Okay, so we have 3 times 9 plus 1 divided by 4. So we would have 3 times 10 divided by 4. So next we would have 30 divided by 4. So what is 30 divided by 4? That is equivalent to 7.5. So 7.5 observation. Okay, so now, same manner with what we did with our Q1. So we are supposed to get the mean as well of our 7th and 8th terms in our data. So here, let's count 1, 2, 3, 4, 5, 6, 7, 8. So therefore, we are supposed to get the mean as well of this 55 and 65. So we have here Q3 equals 55 plus 65 divided by 2. And with that, we would have 55 plus 65, it's 120 divided by 2, then we would have 60. So therefore, our Q3 is 60. And for our interquartile range, of course, we just simply subtract 60 by 34.5, and with that, we can have 25.5 as our interquartile range. And as easy as that. So, of course, I'm gonna share to you first how are we going to give interpretation as well for the results that we've got in our ungrouped data. So, same with our group data, guys. For example, we got our first quartile a while ago as 34.5. So, you may write your interpretation this way: at most 25% or 3 of the students get a score less than 34.5, and at most 75% or 7 got a score higher than 34.5. Here, guys, I know you are wondering, how are we going to get the 25% of 9 students? So you will just simply get 2 point something, but you may just simply round up. Okay, so 2 point something, so let's just count it as 3 students instead of just 2. So round up. So 3 students, and 75% of 9 is 6 point something as well, and then let's just round up as well, so 7. So, and that's it. Okay, next, for your interpretation for your third quartile that you've got a while ago as well. So you just simply write your interpretation this way: at most 75% or 7 of the students got a score less than, so we got 60 a while ago for Q3, so less than 60, and at most 25% or 3 students got a score higher than 60. Okay, so as easy as that. So that's it for this video. I do hope you learn about introduction on quartiles, and at the same time solving for quartiles of ungrouped data. So again, thank you so much for watching, and see you on our next video lesson. Bye!